My teammates are Akil and Gautam. Today we are presenting Dragonfly Algorithm, which we use in natural inspired competition. Introduction about this topic is it's a natural inspired or optimized algorithm, just like a real Dragonfly moving in a group. Flow follows a leader, avoid enemies, and find food. The algorithm copies that behavior to find the best possible solution for the complex problem. The next part will be explained by Akil.
Now I'll be explaining about the pseudocode. But before the pseudocode, we should understand about the social behavior rules of Dragonfly algorithm. So it has five social behavior rules. First is separation, which means avoiding crowd, and the second is alignment, which means match direction. Third is cohesion, which means move towards the nearby dragonflies, and fourth is the food attraction, which means moving towards the best solution. And last is the enemy distraction, which means moving away from the worst solution. So now the pseudocode. The first step is the initialization, where we begin by initializing a population of dragonflies. These are the candidate solutions. Then we create a step vectors and we set a algorithm parameters like neighborhood, radius, speed coefficients, and number of iterations. Then we evaluate the fitness of the dragonflies by using a objective function. Then the third step we enter the loop where we check if a dragonfly, another dragonfly is present within the neighborhood radius. If a dragonfly is present within the neighborhood radius, then apply the social behavior rules or swarm rules, which include separation, alignments, cohesion, food factor, and enemy factor. Then we update the step factor. If there are no neighbors, then we use random walk. Then we update the position and return the best possible solution. Then we end the loop. Now the flow chart. The first step in the flowchart is the start, where we start the algorithm. Then we initialize the population and the other parameters. Then we check if there are neighbors. If there are neighbors, then we apply the five behaviors. If there are no neighbors, then we apply random walk. Then we update the position. If the stop condition is reached, then we end and get the best solution. Now Gautam will explain the mathematical formulation and working mechanism and key features.
Now I am going to explain the working mechanism, how the Dragonfly procedure is worked. Starting at it initializes the population. Start with the dragonfly set of dragonfly representing the candidate solution, and step 2, it identify the neighbors within the radius. Use a specify radius to detect the nearby dragonflies to move towards them, and it apply 5 social behaviors. Example, the 5 social behaviors are separation to avoid collision, alignment to move match the direction of neighbors, cohesion move toward the center of neighbors, center nearby dragonflies, attraction to the move towards the best solution, distraction from enemy, it avoids the worst solution. Update the position. The updation is done using the step vector to modify the dragonfly's location. No neighbor, if there is no updation is needed, if there is a worse solution, it moves away from the solution. And check stopping condition, continue update until termination or criteria meet, and return the best solution. Here is the mathematical formula we use. Delta x is equal to w dot delta x plus small s capital S plus small a capital A plus small c capital C plus small f capital F plus small e capital E. The capital S, A, C, F, E are separation, alignment, cohesion, food, and enemy vectors. The small S, A, C, F, E are the weight with respect to these behaviors. And the position update are x t plus 1 is equal to x t plus delta x. The key features used are 5 social interaction and intelligent movement, and it strong balance between the exploration and exploitation. Here you can see the exploration, how dragonflies explores, and it is the exploitation, how dragonflies move towards the best solution when a food source is found. and it follows simple structure and few parameters for finding the best solution, effective on complex and multi-model search spaces. The next part of advantages and applications is explained by Karthik.
Advantages and limitations. Advantages are easy to implement. The algorithm has simple rules and formulas, so it's beginning friendly. Doesn't need complex maths. Strong global search capability works well for uh, complex problems and balance exploration exploitation. Some of the limitations are parameter sensitive. The algorithm depends heavily on the parameters like weight, radius, and coefficients, and slower in high dimensional space. If the dimension is more, the algorithm will works very slowly and requires proper neighbor radius. In the radius it too large or the small, the dragonfly may not behave properly. And the next part applications are future selection. Used in the Dragonfly algorithm is used in machine learning to select the most important feature from the large dataset, and clustering helps in grouping the similar data points. Scheduling and routing, job scheduling, vehicle routing, and network path optimization, future optimization, and the etc. By this, we are ending our presentation.
This is a final poster which is by done by our team members. Thank you.